Hi everyone, this is TSR. Thanks to everyone who are supporting us, and this is a very good chapter we are going to discuss today. Third chapter of 10th class mathematics, that is polynomials. Very important for public examinations, because from this guarantee 6 marks question will be there, that is polynomial graph. Polynomial graph will be there in every board examination paper. So remaining model problems also very simple to understand. I will give very clear explanation. Okay, just listen, practice and get excel in your subject. Now we are going to discuss about that one, right? Now the topic name is polynomials. First of all, we will discuss about the definition of the polynomial. Next, degree of the polynomial. Next, types of the polynomials. Then, zero of the polynomial. Like that we will discuss. Okay. Among them, first one is definition of polynomial. What is meant by polynomial? An algebraic expression in which variable power is whole number. Variable power is whole number. Whole number means non-negative integer. Then that algebraic expression is called as polynomial. Once again I am explaining, algebraic expression in which the variable power is a whole number, means non-negative integer, that algebraic expression is called as polynomial. Generally polynomials are represented with p of x, q of x, g of x, f of x, like that. Okay. So the general form of writing a polynomial is a naught into x power n plus a1 into x power n minus 1 plus a2 into x power n minus 2 plus and so on plus an, where a naught is not equal to 0. First term x power n coefficient a naught is not equal to 0. Okay. In this kind of general expansion, in every term variable power must be a whole number, means we need to consider the variable powers as 0, 1, 2, 3 and so on only. Means we are not supposed to take any negative values, these are not allowed, and we are not supposed to consider variable power as fractions 2 by 3, 5 by 9, like that are not allowed. Then if the variable power is having other than whole numbers as the powers, that will be called as just algebraic expression. It will not become a polynomial. Understood? Simple example I will try to give. First one, p of x equal to 5x square minus 7x plus 9. 5x square minus 7x plus 9. So this is an algebraic expression. Observe that in the first term variable power is 2, which is a whole number. In the second term minus 7x, variable power is 1. In the third term 9 is there, it is a numerical value, constant. If 9 is there, we can consider its multiple as x power 0, because a non-zero number power is 0. Something power 0 will be treated as 1. Okay na? Okay na? That's why 9 into 1 will be taken as 9. So then variable power is 0, which is a whole number. So in this condition, algebraic expression 5x square minus 7x plus 9 is having variable powers as whole number. That's why this is a polynomial. Okay, whereas I am giving one more, p of x equal to 3x square minus 5 root x plus 1. Observe that, Nana. In this, variable power is 2 whole number. Happy. In this condition, variable power x power is root. Root means whole power 1 by 2. Whole power 1 by 2 means it is a fraction. We should not consider. That's why, forget about the remaining terms, whomever they may be. It is not a polynomial. It is just an algebraic expression. Understood? In the same way, third example, p of x equal to some 4x minus 1 by x plus 3 I have taken. In this first term 4x, variable power is 1, nothing is there means variable power is 1. In the second term minus 1 by x is there. Minus 1 by x means we can write that one as 4x minus x power minus 1 plus 3 model also. So variable power is minus 1, negative value, which we should not consider for the variable power. That's why without checking the remaining values, if any term is having variable power as non-whole number, means negative numbers or fractions like that, that's it. It is not a polynomial. Like that you can easily identify whether the given algebraic expression is a polynomial or not just by verifying the variable powers as whole numbers. Keep it in mind. This is general expansion. Simple examples I had given. After knowing the definition of polynomial, right Nana? So we discussed about the definition and general representation of polynomial. From that we will go to discuss about the degree of polynomial. Degree of the polynomial. What is meant by degree of the polynomial? If it is a polynomial, means first of all it should become a polynomial. Then highest power of the variable. What I wrote? Highest power of the variable. Highest power of the variable is called degree of the polynomial. Is that clear, Nana? So once again I am explaining. To check whether it is a polynomial, to check whether the given algebraic expression is a polynomial or not, we are verifying variable power in every term. If it is whole number, if it is non-negative integer, then only it will be called as a polynomial. So in that process only, automatically after becoming polynomial, if you are able to recognize the highest power of the variable, that highest power of the variable is called degree of the polynomial. Okay, Nana? So some examples I would like to give you. First one, p of x equal to 5x square minus 6x plus 7. In this, variable power is 2 whole number, here variable power is 1 whole number, here constant means variable power can be treated as 0. So 2, 1, 0, those are all whole numbers, that's why it is a polynomial. Happy. Next, automatically what is the highest power we recognized? 2. So that 2 is called degree of p of x. How much, Rana, that one? Equal to 2. So this is the simple way to write the degree. degree of p of x equal to 2. Okay, one more example. Second one, f of x equal to 3x minus 4x cube plus 9x square plus 5. This one. In this also, first of all, it is an algebraic expression. Check it out. In the first term, variable power is 1 whole number. In the second term, variable power is 3 whole number. In the third term, 9x square, variable power is 2 whole number. Last term is 5 constant into x power 0 can be taken, that is also whole number. So, in all the terms, variable power is whole number, that is why it is a polynomial. Okay. Automatically in that process, what we recognized, what is the highest power of the variable? Here we got it as 3. Highest power of the variable as 3. Are you understanding my point? So, degree of f of x equal to how much, Nana? This one 3. Understood? Right. Here one more point I would like to give you, coefficient. Coefficient of the term. So, in this example, x coefficient is 3, x cube coefficient is minus 4, x square coefficient is 9. Okay, na? These are the simple points we have to remember. They came in 9th class, in 8th class. Okay, na? Coefficient. Coefficient of, in this example, x square is how much, Nana? X square coefficient is 9. Like that, you should be able to understand what is coefficient of the term, what is the degree of the polynomial. Okay, right. Okay, Nana. After the discussion of knowing the degree of the polynomial, based upon the degree of the polynomial, you can tell the types of the polynomials. I will give small chart here. Okay, degree, type or name of the polynomial, and example for that one, general example, general form. Okay, Nana, just observe that one neatly. If degree is 0, if degree is 0, then that is called as non-zero constant polynomial. Non-zero constant polynomial. Okay, examples, p of x equal to k. K is any real value. K belongs to R, such as p of x equal to 1 by 2, p of x equal to minus 9, like that you can take. These are the simple examples. Except 0, except 0, remaining all real values as called as examples of non-zero constant polynomial. Okay, Nana? Name of poly is this, its degree 0. In the same way, if degree is 1, then that is called as linear polynomial. Linear polynomial. Okay. General form, p of x equal to ax plus b, where a not equal to 0. General form, p of x equal to ax plus b, where a not equal to 0. So, one more example, p of x equal to 3x minus 2, and so on, like that you can take. With variable power 1, highest power 1, automatically degree will become 1, it is called linear polynomial. If degree is 2, that is called as quadratic polynomial. Quadratic polynomial. General form, p of x equal to, remember this one, Anna, ax square plus bx plus c, where a not equal to 0. Simple example, 3x square plus 4x minus 5, comma, and so on. Infinitely many types you can take. Okay, Nana? Among them, one I am writing. Okay? you should remember general form, condition and some of the examples. Okay Nana? Right. Now if degree is 3, that is called as cubic polynomial. Cubic polynomial. General form p of x equal to ax cube plus bx square plus cx plus d, where a not equal to 0. Highest power of the variable coefficient should not be equal to 0. Simple example, 2x cube minus 5x square plus 6x plus 1, okay, and so on you can take. Okay Nana, that is about cubic polynomial example. In the same way, if degree is 4, we can write that one as quadratic polynomial. Okay, simple example, p of x equal to ax power 4 plus bx cube plus cx square plus dx plus e, where highest power of the variable coefficient a not equal to 0. Okay Nana, a not equal to 0. Simple example, 7x power 4 plus 9x minus 2 and so on, like that infinitely many examples you can take. Those are the different types of the polynomials according to our syllabus, just based upon degree. Okay, and depends upon the number of terms of the algebraic expression, you can also having types of the polynomial. If a polynomial is having only one term, that is called as a polynomial which is a monomial. In algebraic expression also, if it is having one term, it is called as monomial. It may be polynomial, may not be polynomial. So, okay, if algebraic expression is having two terms, it is called binomial. It may be polynomial, may not be polynomial. Checking should be done according to previous concept. If algebraic expression is having three terms, it is a trinomial. It may be a polynomial, may not be a polynomial, checking is needed. Okay, like that, depends upon the number of terms, you can give the names, monomial, binomial, trinomial, multinomial, like that, but they may be polynomials, may not be polynomials. Okay, whereas according to degree, we should know the names of the polynomial and their general forms, because in the exam in bits they will ask some of the questions from this table model. Okay Nana? Okay, what is the degree of the linear polynomial, like that they can ask. Okay, remember that one. Okay Nana, we discussed types of the polynomial based upon degree. Okay, now very important simple point, that one is 0 of the polynomial. 0 of the polynomial. Okay, what is that one? If there is a polynomial p of x, here x is called variable, p of x total is called polynomial. Everybody is clear about that. If we change the variable value, x value as 0, x value as 1, x value as 2, like that, automatically polynomial value p of x will also changes. For example, at x equal to 0, polynomial value p of x is, with some example, p of x equal to 2x square minus 5x plus 3. Okay, with this example of polynomial, at x value 0, variable value 0, polynomial value will become 2 into 0 square, 2 into substitute x value 0 Nana. Okay, variable value, that is it, and simplify, minus 5 into 0 plus 3. then it is equal to 2 into 0 is 0, minus 5 into 0 is 0, plus 3 is final value 3. Okay, Nana? Now, once again I am repeating, variable value is 0. Then the polynomial value is 3. If variable value changes to 1, x value 1, then polynomial value will become p of 1. So, here also you can take polynomial value p of 0. Clear, Anana? So, p of 1 is equal to, substitute x value 1, that is 2 into 1 square minus 5 into 1 plus 3. Simplify its value neatly. 2 into 1 square value 1, 2 ones are 2, minus 5 ones are 5 plus 3. So, 2 minus 5 is minus 3, minus 3 plus 3 is finally 0. We got 0. Okay, Nana? So, at some variable value x equal to 1, polynomial value we got it as 0. Same, at x equal to 2, polynomial value will become p of 2. That is 2 into 2 square minus 5 into 2 plus 3. Simplify them neatly. 2 square value 4, 4 2s are 8, 2 5s are 10, so minus 10 plus 3, altogether 8 minus 10 is minus 2, minus 2 plus 3 is plus 1. This is polynomial value. Now, as the total, what I am going to give you is conclusion. If variable value changes, polynomial value will also get changed. The variable value, who makes the polynomial value as 0? The person of x. Who makes the polynomial value 0? Here polynomial value 3, here polynomial value 0, here polynomial value 1. Like that, polynomial value is 0, that one is taken at x value 1. So, who is the variable making the polynomial as 0? X value 1. So, this fellow is called, that variable is called 0 of the polynomial. Is that clear, Nana? The variable value, I am writing here, the variable value which makes the polynomial value equal to 0. Simply, the variable value which makes the p of x equal to 0 is called 0 of that polynomial. Therefore, x equal to 1 is the 0 of p of x in this example. Okay, Nana? Right. Okay, Nana? Is the concept clear? After knowing the definition of 0 of the polynomial, let us come to know how many zeros are possible. How many zeros? If the polynomial degree is n, if the polynomial degree is n, it has at most, remember this word, at most n number of zeros. N number of zeros. That means if degree is 3 cubic polynomial, then that cubic polynomial will have at most 3 zeros. 3 zeros. If degree is 2, that polynomial will have at most 2 zeros. At most means what? 2 is the maximum value. 2 is the maximum value. If degree is 3, that polynomial will have at most 3 zeros, means maximum 3 zeros. Sometimes you will get 2 zeros only. According to algebraic method, 2 zeros only. But its degree is 3. Means what? Among them, one of the 0 will be repeated to become 3. Okay? Actually you will get 2, 1 will come repetitionally, that's why it will become 3. Okay Nana? That's why if the polynomial is having degree n, then it will have at most n number of zeros. Okay Nana? Right. So degree 3 polynomial will have at most 3 zeros, 3 or less than 3. If we got less than 3, repetition of zeros will come and automatically they become 3. If degree is 2, at most 2 zeros. If degree is 4, at most 4 zeros. If less number of zeros are coming, they will be repeated to become 4. Is that clear Nana? Remember that one. Now listen Nana, after knowing how many zeros are possible for a polynomial, we should know one special note point regarding zero polynomial. Earlier total discussion is regarding zero of the polynomial. This is zero polynomial, both are not same. Okay, zero polynomial. What is zero polynomial? The polynomial who is 0 by itself, means the number 0 is called zero polynomial. Understood Nana? Except this number remaining all constants are called non-zero constant polynomial with their degree 0. Means p of x equal to 7, p of x equal to minus 1 by 4, p of x equal to root 3, those are all non-zero constant polynomials, their degree 0. Already I told you. But only one value 0 is called zero polynomial. Okay, its degree is not defined. Degree is not defined. Okay, this point is also very important for bits. What is zero polynomial? Numerical value 0 is called zero polynomial. What is its degree? Degree of the zero polynomial is not defined. Understood Nana? Good. Okay Nana, after the total concept, we should take exercise 3.1, first exercise of the topic. From this, the most important problems towards the board exams are 3, 4, 5. Okay Nana? Remaining problems are regarding what is the degree of the polynomial, what is the coefficient of the required term, like that. Is it a polynomial or not? Just concept based questions are there which are important for bits. You just go through them. Okay. Next, for 1 mark, for 2 marks, the important problems are 3, 4, 5. What is third question? Third question, they are giving us a polynomial and they are asking polynomial values with suitable variable values. Variable value 0, they are asking polynomial value p of 0. Remember that one. Variable value 1, asking polynomial value p of 1, like that. How to find out? Very simple. Substitution of variable value in the polynomial and simplify. Okay Nana? Right. How to do? Given p of t is equal to t cube minus 1, then at t is equal to 0, variable value 0, p of 0 is the polynomial value, habituate like this, is equal to t value 0, substitute here also, t cube minus 1, that is 0 minus 1, 0 minus 1 value is minus 1, that is it, that is the polynomial value. Next, at t value 1, p of 1 polynomial value is 1 cube minus 1, that is 1 minus 1, which is equal to 0. Variable value t1, whereas polynomial value 0. Since the polynomial is becoming 0, we can call this fellow as 0 of this polynomial. Remember that, 0 of this polynomial. Like that, at t is equal to minus 1, p of minus 1 is equal to minus 1 whole cube minus 1, which is equal to minus 1 whole cube value is minus 1, odd power of the negative value is negative only, so minus 1. Minus 1 minus 1 is equal to minus 2. those are -1, not -1 into -1 to become plus. It is -1. So that's why answer -2. Like that you substitute different type of variable values to find out their respective polynomial values like that. This helps us to check whether that given variable value is 0 of the polynomial or not. Among these, t value 0, variable value 0 is not the 0 of the polynomial. T value 1 is a 0 of the polynomial. T value -1 is not the 0 of the polynomial. Like that, verification will be possible to find out the zeros of the polynomial. Clear, Nana? Right. Okay, Nana. Next problem, fourth one. Check whether -2 and 2 are the zeros of the polynomial x power 4 minus 16. Okay, Nana. How to do? How to check the given numbers whether they are zeros or not? Take them as variable values, x values, substitute, simplify. If polynomial is 0, it is the 0 of the polynomial, otherwise not a 0 of the polynomial. Okay, na? Let us do. Solution. Let p of x equal to x power 4 minus 16 be a polynomial. Simply I am writing like that. At x value minus 2, polynomial value p of minus 2 is equal to x value minus 2, substitute minus 2 whole power 4 minus 16. This is equal to even power for negative value will become positive. So that is positive 2 power 4, that is 16 minus 16 equal to 0. Polynomial is 0 because of this variable value substitution. Therefore, minus 2 is a 0 of p of x. That is it. Next number, what is that? 2. So, at x equal to 2, polynomial value p of 2 is equal to 2 power 4 minus 16. 2 power 4 minus 16 is equal to how much, Nana? Simplification. 2 power 4, 16 minus 16 equal to 0. Polynomial is becoming 0. That is why this number 2 is also a 0 of p of x. Like this you can write the conclusion. Okay, Nana? That is it. Okay, Nana? Next problem, fifth one. What is that? Same model, numerical changes. Check whether 3 and minus 2 are the zeros of the polynomial p of x when p of x equal to x square minus x minus 6. What you have to do? These are variable values, x values. Substitute, find out the polynomial value, from that give the justification. Let us do. Let, not let, they had given. So, given p of x equal to x square minus x minus 6 be a polynomial, be the polynomial, sorry, be the polynomial. At x equal to first value 3, polynomial value p of 3 is equal to 3 square minus 3 minus 6, variable value substitution and simplify it, is equal to 3 square value 9 minus 3 minus 6, 9 minus 3 value 6, 6 minus 6 equal to 0. Okay, like that horizontally you can write or vertically also you can write. So, now that one I will give you. X equal to minus 2 is the second option. Then polynomial value p of minus 2 equal to, substitute this variable value in the polynomial, minus 2 whole square minus minus 2, write them in brackets, Nana, because when the variable value is negative, we should be very much careful while simplification. When negative values are coming in the calculation, be careful. It is a speed breaker. If you did not take care about them, automatically marks will be negative. Okay, right. So, minus 2 whole square minus x value minus 2, that is why write it in bracket. This minus is different, this minus is different, minus 6. Okay, na? Right, this is equal to minus 2 whole square value is negative number with even power is positive. So 4 minus half minus 2 means plus 2 minus 6. This is 4 plus 2, 6 minus 6 equal to 0. So polynomial is 0. Okay na? Therefore 3 making the polynomial 0, minus 2 is also making the polynomial 0. Therefore 3 and minus 2 both are the zeros. Like this also you can write, or after the conclusion of polynomial value 0, here also you can write, therefore 3 is the 0 of the polynomial, like that. Okay Nana? This ends first exercise with simple very important problems. Thank you. Please subscribe the channel. It should be much helpful for many of the students. Thank you.